Hi all, this is Shweta Reddy working as Assistant Professor in the Department of Electronics and Communication Engineering from R.M.K College of Engineering and Technology. So today in this video of wireless communication, we are going to see the structure of a wireless communication channel. In the previous video, we have seen the block diagram. So in this video, we are going to explain the blocks which are used in this channel. So this is the block diagram of radio link with digital transmitter and receiver for analog propagation channel. This we have explained in the previous video. In this video, we are going to see each and every block in detail. So we will move on to the next slide. So starting from the transmitter side, the first block that we have is the information source. So the information source provides an analog source signal where this is responsible for generation of messages, that is image or video or audio. It may be anything. So any message or any data that is generated will come to information source. So this is the source of information where my signals will be generated. So all the signals that is generated by the information source will be fed to ADC, that is analog to digital converter. So all the signals, whatever we are generating will be generally it will be in the form of analog, and then for further processing it has to be converted into digital form. That is the reason why we use ADC. So it has to convert all the signals from analog to digital. So this ADC first band limits the signals from analog information source, and then this is done only if it is necessary, and then it converts the signal into stream of digital data, whereas all the informations, that is analog informations, is generated from the source will be converted into digital data, that means ones and zeros. And then the second block we have is the source coder. The source coder is responsible for removal of any redundancy of information in the source signal. So let us take this example over here in this image. Here we have two pictures. So this first image is a raw image which will have quite lot of details in it. And when it is compared or when it is converted into any particular standard, so let us take JPEG for example, then you could see that there are certain details that are missing over here. So this is because of the removal of redundancy information. So most of the information or most of the detailings will be kept, but you can still observe that there are certain informations which have been taken out. So this difference is because of source coding. So here source coding is nothing but it uses prior information on the properties of the source data in order to reduce the redundancy in the source signal. And then later on you have third block, which is nothing but channel coder, where this block will add certain redundancy information. So this block will be adding certain informations that are responsible for error correction and error detection and so on. So as you know that the signal will be sent over any noisy channel, so that my signal or my data will get affected because of lots of factors, whereas attenuation, fading and so on. So these are the lot of possibilities, that is these are the possibilities of my information to, there are possibilities that my information to get some errors. So in order to identify the errors and in order to overcome the error, there must be certain error detection and error correction codes which has to be added to my data. So the process of adding that error detection codes and error correction codes will be taken care of this channel coder. So there are certain examples over here. So for certain types of channel we may use this Reed-Solomon codes to protect, especially when it is against the burst errors. So following that we have another stage that is called signaling. So signaling is an area where we add some control information. So control informations are very much important for establishing and ending the connections. And in order to deliver the messages to correct user, and also the signaling will help you for synchronization and all such things. And also the signaling information is usually strongly protected by error correction codes. So you will have separate error correction codes which will specify correct and specifically correct only the signaling schemes, because the signaling informations are very much important for exact delivery of messages to the exact users at the receiver side. So this actually you can correlate with In computer networks, you might have come across this protocol called TCP protocol. So, whereas this TCP protocol, also called as reliable protocol, and in reliable protocol, by using when you transmit any message, before transmission of message, there will be certain signals that will be exchanged. We call that as handshaking signals. So this handshaking signals are actually making the TCP protocol more reliable one. So these handshaking signals is somewhat we can relate it to the signaling or control informations, which is added here in the mobile communication system. So at an outset, the signaling informations or control informations are very much important in sending the message to the right users, and this has to be heavily protected. And next comes the multiplexer, and you know that what is multiplexer? What does multiplexer do is, as a figure depicts, it collects the inputs from various users, and based on the signaling information, it would be sent as one output. So generally, it combines the data from multiple users. The next block we have is the baseband modulator, where exactly the modulation will happen. The modulation part we will see later in the subsequent videos, but as of now, know that the modulator is a process of assigning a data bit to a symbol. So it is a process of converting messages to symbols. So till now you have data which is in the form of zeros and ones. So from now on, you will be mixing up this message signals with the carrier signal, so that you will end up with any symbol. So you can use any modulation technique. There are variety of modulation techniques available. So we can use any one of the modulation technique in order to make the signals to travel over long distances. However, this high frequency signals could not able to travel over long distance, but still we can take up modulation. It is because of the design factors. So for the low frequency signals, if we use low frequency signals for transmission, then the antennas has to be designed at larger sizes. So sending the signals using high frequency will eventually reduce the size of the antennas. So that is the reason why we modulate the signals over here. There are several versions of modulations available, which will be seen in the later part of the videos. And then the modulation will actually design spectral properties, that is ISI, peak to average ratio, and other properties of this transmit signals, which will decide. And we must also take utmost care on sampling and quantization part as well, because oversampling and quantization will determine the level of aliasing and quantization noise when we are performing modulation. So proper care has to be taken in assigning the sampling rate, which we have done in this analog to digital converter, that is ADC. Then following the modulator, we have DAC, which is digital to analog converter. So before the signal has to be transmitted, all the signals, as far as working on digital signals, so before transmission, all the digital signals has to be converted into analog form. Only then it could be transmitted over an antenna. So your DAC will generate a pair of analog discrete amplitude voltages corresponding to the real and imaginary parts of the symbols. So all the transmit symbols will have real and imaginary part. When you look at the equations of this modulation patterns, you can clearly understand that there will be two parts. One is real part and other one is imaginary part. So that is, there are two components in the transmitted signal. So all those signals will be converted into analog format, and all those analog formats will be passed to the analog low pass filter, in which the transmitter will be eliminating the spectral components which is outside the desired transmission bandwidth. So what are all the components that is spreaded outside the desired bandwidth? All those things will be eliminated by using this low pass filter. So after signals is properly filtered, then this will be fed to the TX unit. So following that, you have TX local oscillator, which will actually provide unmodulated sinusoidal signal corresponding to one of the admissible center frequencies. And the requirements for the frequency stability, phase noise, and switching speed between the different frequencies depend upon the modulation technique that we use. And then we have up converter, which is actually converting the analog filtered baseband signal to a passband signal by mixing it with the local oscillator. And this up conversion can occur in a single step or in several steps. Finally, amplifications in the radio frequency domain is required. And then we have RF transmission filter, which eliminates this out of band emissions in the RF domain. Even if the low pass filter succeeds in eliminating the out of band emissions, the up conversion can lead to this creation of this addition out of band components. And then we have propagation channel. The propagation channel attenuates the signal and leads to delay and frequency dispersion. So this is the end of the transmitter section, and in the next slide we will see about the receiver section. So this is the block diagram of digital receiver chain for mobile communication, which has been explained in the previous video. Now we will see in detail about each and every blocks in the next coming slide. So now here at the receiver side, all the process that we have done in the transmitter side, we are going to do in reverse order to reproduce the signals. So first and foremost step is the filtering part, which is actually which will actually perform a rough selection of the received band. As an antenna, it will receive all the bandwidth that is capable of a particular antenna. That is, out of all the received signals, the required bandwidth is alone has to be filtered out. So this will be done by using the RX filter, and sometimes the tuner will also take this part. So low noise amplifier is the second part which has to be done, because our signal will be buried inside the quite a lot of noises. So in order to make this signal for further processing, we have to amplify the signals. Even before we start processing on a signal, this low pass, that is low noise amplifiers, amplifies the signals, that the noise added up by later components of this receiver chain has less effect. However, the remaining, that is subsequent parts that we are going to see, will add a sufficient amount of noises on the received signal. So already my signal have undergone quite a lot of noises when it is propagated through this channel, and now each and every component of the receiver chain will also add certain noises. So that the signal should be immune, or the signal should be strong enough to deal with all these subsequent stages. So that is the reason why low noise amplifiers are used as the second component, where all the signals will be amplified even before it is sent for the later chain of the RX circuit. So the next will be the RX local oscillator, which provides sinusoidal signals corresponding to the possible signals at the transmitter local oscillator. So the local oscillator at the receiver side will provide sinusoidal signals that is almost equal, or that it is same as the signals that is generated by the transmitter side. So this is what the demodulation process, that is, so uh, the frequency at the local oscillator can be fine-tuned by this carrier recovery algorithms. So what is this carrier recovery algorithm? We will see that in the next slide. So to make sure that the transmitter and the receiver procedure oscillations with the same frequency and phase, so it is important to produce oscillators both at the transmitter side and receiver side at the same frequency and same phase. So amplitude can be adjusted by amplifying or boosting up. So there at the receiver side we have used up converter, and now at the transmitter side we have used up converter, and now at the receiver side we will be using down converter, which actually converts the received signal into baseband signal. And then we have low pass filters, which will filter out only the desired frequency bands for a specific user. So this actually eliminates adjacent channel interference as well as any other noises which are buried inside the received signal. And then we have automatic gain control. Automatic gain control will amplify the signal such that its level is well adjusted to the quantization at subsequent ADC. After that, my signal will be sent to the ADC, where ADC converts analog signal into digital signal. And the next one we have is carrier recovery. The carrier recovery determines the frequency and phase of the carrier of the received signal, and it is adjusted to RX local oscillator. Next we have demodulator. So the demodulator is just the reverse process what we did in the modulator at the transmitter side. So here in demodulator, it obtains soft decision data from digitalized baseband data and hands them over to the decoder. And then we have multiple antennas. If there are multiple antennas involved at the transmitter side, then the receiver must also use these multiple antennas at the receiver side. So then these multiple antennas either select at the receiver side, either selects the signal from one of them for further processing, or the signals from all of the antennas have to be processed. So when we use multiple antennas, we will end up with two choices. One is either I can select one signal from the received signal, or I can combine all the received signals and then I can take out one single output. So that is what the two possibilities when I use multiple antennas for transmission or reception. So next one we have is symbol time recovery. So this uses the demodulated data to determine an estimate of the duration of the symbols and used to fine tune the sampling intervals. And so the next part will be the decoder which uses soft estimates from demodulator to find the original source data. So next we have demultiplexer. The demultiplexer is used to separate the user data and signaling information and reverses possible time compression of the transmitter TX multiplexer. And finally we have source decoder. The source decoder reconstructs the source signal from the rules of the source coding. If the source data are digital, the output signal is transferred to the data sink. Otherwise, the data are transferred to the digital to analog converter, which converts the transmitted information into analog signal and hands it over to the information sink. In information sink, we will be recovering the original signal which is sent at the transmitter. Thank you all.